Every great once in a while, we get a peek into the world of industrial engineering and maintenance, and we see how huge things work. And one of my favorite examples is this series called How They Rebuild the World's Biggest Engines. We gotta go behind the scenes and see how they rebuild train engines, helicopter engines, and even fighter jet engines. But today, we're going to see how they rebuild the United States Air Force's biggest jet engine. So let's take a look. The United States Air Force has some really big jet engines, but we're talking about 4 different engines today. First off, there's the F-117 PW-100 engine used on the C-17 Globemaster, the TF-33 P-3-103 that powers the B-52 Stratofortress, and the CFM-56 variant called F-108, that S used on the KC-135 Tanker. And each of these engines weighs over 4,000 pounds and generates 40,000 pounds of thrust. That's pretty big. So let's start at the beginning. When an engine reaches its service hour limit or shows signs of trouble, it's removed and shipped to a specialized Air Force maintenance depot, like those at Tinker Air Force Base in Oklahoma. These depots are the home of some of the most highly skilled aircraft mechanics in the world. Once the engine arrives, a team of technicians carefully disassembles every part. This includes the fan blades, compressors, and turbines. Each component is logged and inspected before being sent for cleaning and testing. While some parts wear out and need to be replaced, others can be repaired and reused. For example, if a turbine blade is damaged, it can often be fixed by welding the broken pieces back together and then grinding them down until they fit perfectly. Other components, like shafts and bearings, are carefully checked for any signs of damage or fatigue. If they're in good shape, they'll be cleaned and relubricated and put back into the engine. But if they're too far gone to be repaired, they'll be replaced with brand new parts. But what happens when an engine component can't be repaired or replaced? In that case, the part needs to be re-engineered from scratch. And that's where the real magic happens. Using advanced computer-aided design software, engineers can create a brand new part that's stronger and more durable than the original. For example, if a compressor blade has been damaged beyond repair, the engineer can design a new blade that's made from a stronger alloy and has a more efficient airfoil shape. This process of re-engineering parts isn't just about keeping the engine running smoothly, it's also about making it better than ever before. By using advanced materials and innovative designs, engineers can create parts that last longer, operate more efficiently, and withstand the extreme conditions of flight. It's a testament to human ingenuity and the incredible technology that goes into building these massive engines. Next comes cleaning. Technicians use a variety of methods to clean each piece. Some components are placed in acid baths, while others are blasted with ultrasonic waves or high-pressure air jets. This helps remove any dirt, debris, or corrosion that is built up on the parts during their last deployment. It might not seem like the most exciting part of the process, but it is an essential step in ensuring that every engine component is in top condition before it gets put back together. Just imagine trying to run a marathon after taking a long break without training. You'd probably feel pretty sluggish and maybe even a little sore. Well, cleaning the engine components is kind of like taking a nice warm bath and doing some gentle stretches. It helps loosen everything up and get it ready for the big game. In this case, the big game is getting the engine up and running again. After all, you wouldn't try to run a marathon in dirty clothes, would you? Once the parts are all nice and clean, it's time to inspect them. Now it's time to inspect each component to make sure it's in good working order. Technicians use a variety of tools to do this, including borescope cameras, X-ray imaging, and laser measurement tools. These advanced technologies allow them to spot microscopic cracks or warping that might not be visible to the naked eye. But why is this so important? Well, just imagine you reflying an airplane and one of the engine components fails due to a small flaw that was caught during maintenance. It could be enough to cause catastrophic damage, and that's not something you want to think about. That's why these inspections are so crucial. By using advanced technology, technicians are able to identify potential problems before they become major issues They can fix small problems before they have a chance to grow into big ones. It's like taking your car in for a regular tune-up. Your mechanic might not find anything major, but they'll catch small issues that could turn into big headaches down the road. Plus, it gives you peace of mind knowing that your engine is in top shape. But before we move on, I just wanted to say a quick thank you to some supporters. Their generous donations help us keep producing these videos for you guys. And if you want to join them, you can check out the links below. Now, back to the video. Okay, so once the parts have been inspected and any necessary repairs or replacements have been made, the engine is ready to be rebuilt piece by piece. But there's one really important thing to remember here. Everything has to match factory precision down to the thousandths of an inch. So how do they make sure that happens? Well, first off, they use computerized balancing rigs to make sure that every component is perfectly aligned. Even a slight misalignment can cause vibrations that lead to catastrophic failure over time. That's why this step is so critical. It's like making sure that all the wheels on a car are aligned. If they're not aligned properly, it can lead to all sorts of problems down the road. But by taking the time to get it right from the start, they can prevent future headaches. But it's not just about keeping the engine running smoothly. It's also about maximizing performance. Properly aligned components ensure that the engine operates at peak efficiency, wasting less fuel and producing more power. So not only is it safer, but it's more efficient as well. And speaking of efficiency, have you ever wondered how these massive engines are moved around? Well, that's where these come in. These specialized dollies are designed to move the heavy engine safely and efficiently. They have a low profile to minimize the risk of damage during transport and are equipped with locks to secure the engine in place. But they don't just move the engine, they also help with maintenance. The dolly's modular design allows for easy access to different parts of the engine, making inspections and repairs much easier to perform. Plus, they can be customized to fit different engine models, making them a versatile tool for maintenance crews. Overall, these are an essential part of the aircraft maintenance process. They allow technicians to work safely and efficiently, reducing the risk of damage and improving productivity. Finally, it's time for the ultimate test. The rebuilt engine is mounted inside a massive concrete taste cell, essentially a giant jet lab, and fired up to full throttle. Technicians monitor over 100 real-time parameters like temperature, RPM, oil pressure, and fuel flow. If it passes, the engine is cleared for another mission-critical deployment. That's a relief! Imagine all the sweat and hard work that went into this engine, and if it failed the test, they'd have to go back and start all over again. But thankfully, it passed with flying colors. That's how the U.S. Air Force rebuilds its biggest jet engine. It's a fascinating process that requires precision, skill, and cutting-edge technology. From disassembling the engine to inspecting each component to firing it up and testing it to its limits, every step of the way, these highly trained technicians are ensuring that these massive engines are in top condition. It's a vital process that keeps our Air Force running and our skies safe. If you enjoyed this video, make sure to like, subscribe, and hit the bell for more stories from the sky. Thanks for watching. See you next time.